Welcome to Asim Code. If you're ready for more coding adventures, hit like, subscribe, and stay tuned for more tutorials. In this video, our topic is Python Data Structures Showdown, linked lists versus arrays. Arrays, lists in Python. In Python, an array is often represented using a list, which is a built-in data structure. It is a sequence of elements stored contiguously in memory. You can think of it as a row of boxes, each holding a value, and the boxes are placed next to each other in a straight line. Linked list. A linked list is another data structure that stores elements, called nodes, in a sequence. But instead of being stored contiguously like arrays, each node points to the next node in the list. You can think of it as a chain, where each link in the chain is a node containing data and a reference, or link, to the next node. When to use. Arrays, lists in Python. When you need fast access to elements by index. The size of the data is known or doesn't change often. You don't perform many insertions or deletions in the middle. Use linked lists when you need frequent insertions and deletions in the middle of the list. Example, a real-time application where data is constantly changing. Memory allocation is not a concern. The list size changes dynamically and unpredictably. Imagine you are developing a music app and want to allow users to add songs to their playlist. You have two ways to manage the playlist. Using an array list. This is great for small playlists where users mostly want to view the songs in order. Arrays are easy to work with because songs are stored in a simple list. However, if users want to frequently add songs in the middle or remove them, you might run into issues because shifting songs around in an array is slow. Using a linked list. This is more efficient when you expect users to add and remove songs often, especially in the middle of the playlist. Since each song in the linked list has a pointer to the next song, adding or removing songs does not require shifting the entire list. However, finding a specific song in the list is slower because you need to traverse from the start. This example demonstrates how to manage a playlist using two different data structures. Array, list in Python. Simple and fast for accessing songs by index but inefficient for inserting/removing songs in the middle. Linked list, efficient for inserting/removing songs from any part of the list but slower. Linked list node class to represent each song in the playlist. Song_name. This variable stores the name of the song. It is passed as an argument when creating a new node song. For example, song 1, song 2, etc. Next, this variable points to the next node, song, in the linked list. Initially, it is set to none because a newly created song does not point to any other song. As songs are added to the playlist, the next will point to the next song in the list. Playlist class to manage the playlist using a linked list. Head. This variable points to the first song in the playlist. If the playlist is empty, head will be none. Function to add a new song to the end of the playlist. New underscore song. This variable stores a new node, song object. We create a new song node by passing the song name as an argument. The song name is passed when calling the add underscore song function. If the playlist is empty, the new song becomes the head of the playlist. This means there is no previous song, and we simply set the head to point to this new song. If the playlist already has songs, we need to traverse to the end of the playlist and add the new song there. This is where we find the last node in the list. Start from the first song, head, in the playlist. Traverse through the playlist until we reach the last song. Once we have reached the last song, where last underscore song dot next is none, we link it to the new song by setting last underscore song dot next to new underscore song. Function to display the songs in the playlist. Current underscore song. This variable is used to traverse the playlist, starting from the first song, head. Traverse through all the songs in the playlist, printing each song's name. Print the name of the current song. Move to the next song in the playlist by updating current underscore song. Current underscore song dot next points to the next node, song. Example using a Python list, array, to store the playlist. Playlist. Here, we create a simple list of song names. The list represents an ordered collection of songs. Print a message indicating we are using the array-based playlist. Loop through the array and print each song. Example using a linked list to store the playlist. Playlist. Create an instance of the playlist class, which uses a linked list. Add songs to the playlist using the add_song function. Print a message indicating we are using the linked list-based playlist. Show all songs in the playlist using the show_playlist function. Run both examples. Key takeaways. The array, or list in Python, provides fast random access but can be inefficient when modifying the list. The linked list allows easy insertions and deletions, but finding a specific item is slower because you have to go through the list one item at a time. Now run our code. I hope you enjoyed the video. Be sure to like, subscribe, and turn on notifications.